Hello. Okay. Uh, as you know, you are required to have a financial calculator for this course. I am allowing you for the test to use your cell phone. You can download an emulator for free. You have to go through, you have to basically have the ads come on if you get it for free, or you can pay uh, a small fee. I think it's $5, so you don't have to watch the ads anymore. Anyway, uh, the most common calculator and the emulation, if you get the emulation, you should use is a Texas Instrument BA2, which is right here, and this is the emulator. Okay, now if we look at our PowerPoint here, FV is future value, and that would correspond to right here. PV is present value right here. I over Y is interest rate of the period right here. And N is the number of periods. N. Now, PMT we'll use in later chapters. For this chapter, it's going to be 0. Okay, so moving on. I over Y, right? C over Y must equal 1 for I over Y to be the period. In other words, the default period is 1 period, and that's a default on the BA2. Interest is earned as the actual numbers, not a decimal, as would be in Excel or if you're doing the formula. As we said, PMT for this chapter is going to be 0. Now, going back to the calculator, we want to basically clear, before we start each problem, we need to clear all the information so we don't have bad information going around or in our calculation, excuse me. And basically the way we do this is we hit C, and in this case, clear work CI. Oops. So I'll hit second, and I'm going to clear my work. Okay, it says TMB there. Or I can just go ahead and re-enter each field, which is okay if you have a new problem. You enter each field, and I'm sorry. It's second, clear TMV, which is right here, TMV. Both work actually though. So moving on, I set the number of decimal places, right? And here we're going to do 4. So to do that, we'll do the following. Right, I'm going to hit the second key, second, and then I'm going to hit format, which is above the period right here, format. And then I'll hit the decimals. In this case, the desired is 4, and then I'm going to hit enter. Oops. And I keep trying to do it with the button, but the button doesn't work. I'm sorry. I keep doing it on the computer instead of my cell phone, which this is my cell phone transporting onto this recording. Okay. I want to make sure the POY is set to 1, and the way I do that is as follows. I basically hit second, and then POY is right over I of Y, which is right here. So I hit I of Y. I enter 1, which is a default, so I'll just leave it there. And then I hit enter, also enter. And that is it. And then I press CEC to get to 0. I have to hit it twice. I want to be sure that the calculator is set for cash flows at the end of each period. And we'll do both later on, but the default is end, but we're going to go ahead and do it anyway and make sure it's the default. So here we go. I'm going to press the second key, right? And above the PMT, I have begin. So I'm going to hit PMT right there, PMT, which is a toggle switch between end and end. To change, right, I'm going to hit second and then hit set, which is the enter, and it changes to begin. Now, I don't want begin, right? But just to show you that when uh, we're doing something with begin, I'm going to have BGN right here. So begin mode, of course, end mode is the default and nothing will be indicated here. So right now we're begin. I don't want begin, so I'm going to hit second, uh, then begin, which is above PMT. And basically I I want to hit second set to hit end. There I have it. And then I'll hit clear, and now the begin's not up here anymore, so we know we're at end. Okay, so here we have the formula, right? Suppose I invest $100 from the previous example for 5 years. How much would you have? Well, basically we do this, and we can do this with the calculator. Uh, so why don't we go ahead and do it with the calculator? What the heck? So here, the present value is $100. 1 plus r is 1 plus 0.1 or 1.1. So I have 1.1, oops, 1.1 to the fifth power, this is 5 years. And to get that, I'm going to hit over here, y to the x, hit y, and to the x, and I'm going to hit 5, and then I'm going to hit equal, and that gives me 6.105. I'm going to multiply that by 100. Oops, what happened? Okay, let's try that again. 1.1 y to the fifth. Oops. And multiply that times $161.05. Of course, we have a little bit of spillover. Uh, so 101, and this is a typo. It should be 051, not 105. This is right though, 161.05. Oh, that's right. Sorry. And of course, we have a little bit of rounding, 0.1. Okay, moving on. Here we have that same thing. Basically, we're earning 10% a year. So I have $100. That first year, I earn $10 in interest, and I get $110 at the end of the period. Then I'll have $110 at the beginning of the period. I'll earn interest on that, which will be $11. I'll make $121 at the end of the first period. At the beginning of the third period, I have that $121. I earn $12.10. I'll have $133.10 at the end of the third period, which is the beginning of the fourth period. I earned $13.31 in the fourth period for $146 and 41 cents, which is the beginning of the 5 period. Then I earned $14.64. I add that to all that I have, and I have $161.05. So off that $100, I'll have earned $61.05 off those 10 years. And here it is. We have basically $100, and the green, as we're going to see, is simple interest, where the blue is compound interest. So basically, I earned $10 that first year in simple interest. I earned another $10 in simple interest second year, the third year, the fourth year, the fifth year. That interest on interest, or that compound interest, are these blue lines, which we'll see now. Right. Oops. Let's see the next slide. Okay. So going back to Well, we did this with the formula using the calculator. Now we'll do it using the keys of the financial calculator. So I'm going to clear what we had before, right? I'm going to hit N equals 5. There's 5 years. It's 5, N, and then I enter. So 5, and I hit N, and then I hit enter. I over Y is 10, so I'm going to hit I over Y, 1 0. Sorry, 1 0, I over Y, enter. You got to enter the number before you enter the thing. Then I'm going to enter the present value, which in this case, this is what I put in to get the future value, so it's going to be negative. So 100, present value, and then I hit enter. Right there, enter. PMT is 0. We'll go ahead and do that just because we can, even though that is the default. Enter. And then I want to hit compute, CPT, which is right here, CPT, future value. So compute, future value. Here we go. Compute future value is $161.05. By the way, that should have worked even when I did have the PMT. So 0, PMT, enter, compute, future value. There we go. It was $161.05. Now I can do this also with an Excel spreadsheet. And here, basically, the functions that we've had so far. Basically, if I have basically for what I need, if I have the interest rate, the number of periods, the payments, which in this case is 0, and the present value, I can calculate the future value. If I have the other 4 things, I can calculate the present value. If I have these 4 things, I can calculate the rate. So I have the number of periods, the payments, present value, and future value. I can calculate the rates, and I can calculate the number of periods if I have the rates, the payments, present value, and future value. So here is it. So just at the beginning, what I'd like to do is FB for this first one. First thing is I want the rate, which is 10% or 0.1. Next is the number of periods. In this case, the number of periods is 5%, or 5 years, sorry, not 5%. Payments, as said, the default is 0. Present value here is going to be negative 100. And then we have type, which I'm going to go ahead and put, even though default is 0, which means it's compounded at the end of the period. And boom, we get $161.05, just like we have here. Of course, I could do it with this. Here, present value, P12, which is 10%, that's the rate. P11 is the number of periods. P14, which is right here, which is the payment, 0. And finally, P15, which is a future value. And that'll give me the present value, which is $100. And of course, it'll be negative because that's what we're putting in now. Okay. Let's see here. Here we have the number of periods. Here, B24. B24 is 10% or 0.1. B26 is the number of payments. That would be 0. B25 is I over Y, which is our present value, which is negative 100. And P27 is our future value, which is 161.04, and it gives me the number of periods is 5. Did we do the rate? I'll do it again if I hadn't. So B17 is the number of periods, 5. B20 is the payment, which is 0. B19 is the present value, which is negative 100, and B21 is $161.05, which is our future value, and that gives us the interest rate of 10%. Okay, so that's how we do it in Excel. Now, suppose I had a relative that deposited $10 at 5.5% interest for me 200 years ago, my great 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 grandfather or grandmother. How much would the investment be worth today? Well, we can do it with the formula, right? She's right. Well, let's go ahead and do it with the formula. Well, we still need the calculator because I can't do this in our head, or most of us can't do it in the head. Maybe some of you can. So 1 plus r is 5.5. It's 1.05. 1.055 is our interest rate. And I want to basically raise that to the 200 power. So x over 200 equals 44,718.9839. And basically, to get our final answer, I want to multiply that by how much he put in, which was $10. That was the present value 200 years ago. So I hit times 10, and I hit equal, and it gives me $447, $189, and rounding up 84 cents. Okay. So we can do this with the calculator. In this case, right, the number of periods, n equals 200. I hit 200 and enter. The interest rate is 5.5, I over y, enter. The present value is 10. So it's 10, present value, enter. The number of the payments is 0. We only have 1, so I have 0, payment, enter. Again, we don't have to do this because that's the default. And what I want to do is I want to compute the future value. So I hit CPMT, future value, and there it is. I get negative $447, 189, and basically 84 cents. And that's because the present value we had positive. We could have made it, if we would have made the present value negative, the future value would have been positive. So yeah, so remember that at least one has to be positive, either the future value or the negative value, or later on payments. But it's usually the present value is negative because it's how much you put in. Unless it's a loan, then the future value will be 0 or negative. Okay, and then finally, we're going to have the Excel solution, which is the future value. So I'm going to hit future value. Hope you guys can see this is the rate. Again, when we do it in Excel, it has to be in decimals. The number of periods is 200. Payment is 0. Present value, here I'm going to make it negative 10. Now, if I would have done this positive 10, the type is 0. The default is 0, so I'm just going to leave it there. And oops, something happened. That's wrong. Let's see. Oh, instead of negative 10, I'm going to say shift and I hit underscore. And there it is, $147,189.84. There we go. Okay. The next example, suppose your company expects to increase unit sales of widgets by 15% per year for the next 5 years. You currently sell 3 million widgets in 1 year. How many widgets do you expect to sell in 5 years? Well, this one basically, our growth rate of how much widgets we sell is going to increase 15% per year for the next 5 years. So it's real easy. Right now we're selling 3 million. All right, the growth rate is 15%, so 1.15 for the next 5 years to the 5th power. So 1.15, if we do it in our calculator to the fifth power, give us 2.0114. I wasn't going to do it, but I might as well go ahead and do it. Okay. So I have 1.15 to, right, I hit y to the x, right, to the fifth power, and that equals 2.0114. And of course, I multiply that by 3. And of course, that would be 3 million. And that would give me 6.0341 million. Okay, so that's how much widgets I expect to sell in 5 years. Now, I can do this with the calculator, with the financial calculator. First, I hit 5N, enter. Then the interest rate, or the growth rate in this case, is 15%. So 1.5 I over Y, which is the growth rate here, enter. The present value is 3 million, but we're just doing it with it. So I'm going to hit 3 PV, which is present value, enter. PMT is 0. The default is 0, so I'm going to leave that alone, and I'm just going to hit compute future value. There we go, which is negative 0.0341. It's negative because we made the present value positive. Okay. So let's go ahead and do this. Well, here, let me erase this so it doesn't get too confusing. Let's go ahead and figure out the future value of how many widgets we're going to sell in Excel. First, I do the rate, which is 0.15. That's 15%. Again, in Excel, you have to do it in decimals. The number of periods is 5 years. The payment here is 0. The present value is 3. And of course, the type is 0 default. So I'm just going to go ahead and do 0, just because the book didn't. And voila, that gives me $6.03. And it would be 41 if I did the decimals. Here, let me format the cell and increase the number of decimal places. And there it is, 0.03407. Basically what we have there. Okay, and that's how we do it in Excel. The next example, or the next we're going to do is for given interest rates. We're going to notice the relationship between the interest rate and future values. The longer the time period, right, the higher the future value for a given interest rate. So for a given interest rate, as time increases, my future value increases. Why? Because I'm going to earn more and more interest as time goes on. It's pretty simple. So for a given time period, right, the higher the interest rate, the larger my future value is. In other words, I earn more interest for a given time period as the interest rate increases. And here we have a graph. If the interest rate is 0, basically after 5 years, I have 0. If it's 5%, right, for $1, we'll have so much. 10%, I have more. 15%, I have even more. Or 20%, I have more. And you can see as time goes on, right, for each interest rate, right, the amount of money that $1 generates goes up and gets bigger and bigger. It's a lot bigger at 20% than it is 5% after 10 years here. And of course, if you have 0%, you don't earn any interest. The future value stays the same. Okay. So here we have quick. Suppose what's the difference between simple interest and compound interest? Right? Simple interest we learned in the last graph. Simple interest is only on the original principal. Compound interest is interest earned on principal and interest received, interest on interest. So suppose I have $500 to invest and you believe that you can earn 8% per year over the next 15 years. How much would I have at the end of 15 years using compound interest, and how much would I have using simple interest? Now, if I'm doing simple interest, right, I just multiply 0.08 times 500. And that's what I get every year for 15 years. I don't get any interest on interest, but with compound interest, I do. So, all right, oops, let's look at the solution. Here, n is 15, 8 is I over y, the present value is negative 500, and when I compute the future value, I get 1,583. So let's go ahead and do that with the calculator. So here, 15 is n, so 15n, enter. 8 is the interest rate, 8 I over y, enter. Purity of 0, that's the default, so I'm going to leave that alone. And finally, I have 500, and I'm going to go ahead and make this negative because that's how much I put in. And it's negative 500, PV, enter. And I want to compute future value. So I hit CPT, future value, and that gives me $1,586.08. Just like here, right? We can do this in Excel, basically with this formula here. Let's go ahead and do that. That equals future value. The rate is 8%, and again, in Excel you have to do it in decimals, so 0.08. 15 is the number of periods. 0 is the number of payments, or what you get each payment. And then the payment is negative 500, or the present value is negative 500. And again, I'm going to do the default, which is 0 in the type, just to see it as default. And we get the same thing, $1,586.08. Okay. How much would you have using simple interest? Well, basically, as I said, you take that 500 and multiply by 0.08. Uh, which if we use the calculator, right, we'll see 500 times 0.08, that equals $40. So basically each year I get $40 in simple interest. I multiply that by 15 because it's 15 years times 15. I think I hit something wrong there. Let's see. 500 times 0.08 gives me 40 times 1, 5, gives me 600. Not 200. I must have not hit the 1 right a little while ago. Be careful. So I had $600 in interest, in simple interest. And I add the $500 that I put in originally, and I get $1,100. That's how much I have in simple interest. Of course, the difference, that $486, is what I get interest on interest or compound interest. Okay. Questions? Oh, sorry, you can't ask questions. It's recording. Okay. Uh, Next, we're going to do present value. Present value is simply the current value of future cash flows discounted at an appropriate discount rate, and in general, that's going to be our interest rate. Basically, it's value at t equals 0 on our timeline. So basically, it answers the questions: how much do I have to invest today to have the same amount or have some amount in the future? What is the current value of some amount received in the future? All right. So the present value is the current value of an amount to be received in the future. Uh, so if you have a bond, why is it worth less than the face value? And the reasons are, as stated, opportunity cost. I can get that money and invest it somewhere and earn interest. So therefore, if I buy a bond, uh, and what you learned in hopefully in your other class, your other finance class, a zero coupon bond, it's going to have less. It's going to be worth less than the face value when you buy it. And of course, there's risk and uncertainty. So the discount rate, right, or that interest rate that you use to discount the present value, is going to be a function of time. and how much risk you have. So the tick marks, right? Today is time 0. This is where I have the present value. Time 1 is end of period 1. Time 2 is end of period 2. Time 3 is end of period 3. So basically, our cash inflows positive. That means our cash flows were negative. And of course, my payments is constant cash flow. And for our purposes, our payments are going to be 0. So here it is. Here's our future value calculation. Future value is equal to present value 1 plus r to the t. That means present value has to equal future value. I divide 1 plus r to the t divided by 1 plus r to the t. Now, 1 over 1 plus 1 to the t, right? Just using algebra, you can write as 1 plus r to the negative t. Discounting, basically, finding the present value of one or more future amounts. Uh, so suppose I need $15,000 in 3 years. I can earn 6% annually. How much do I need? Well, let's do it. Under 15 in 3 years is 6%. How much do I need to invest today? I can do this with the calculator. I can do this with the formula, right? And here's the formula: 1,500 divided by 1.06 to the third. 1.06 to the third is 1.190116, right? I divide that by 15,000 and I get $12,594.29. So you get that $15,000 in 3 years, uh, right? I need $12,594. Now, I could have done this with Excel here with this formula, or I could do it with the calculator. So let's go ahead and do those two things real quick. So here with the with the calculator, 3 and enter, 6 I over y, enter, 1,500 or 15,000, excuse me. Oops. 15000 is my future value, enter. PMT is the default, which is 0, so I'm going to ignore that. And basically what I want to do is I want to compute the present value. And voila, since the future value is positive, the present value has to be negative, which is $12,594 and rounding 29 cents. Now finally, we want to do this with Excel. And here I want the present value, so equal PV. The rate is 6%, and again, in Excel, you have to use the decimal, 0.06. The number of years is 3. Payments is 0. And the future value is 15,000. Again, I'm just going to use 0 just to remind you guys that that's the default. Oops. And I have an error. Oh, I have one too many commas here. Okay. There it is. $12,594.29. Of course, it's negative because we made the present value positive. Okay, return to the quiz. If I can invest 8% instead of 6%, how much would I need? So if I get 8% instead of 6%, right, n equals 3, 8 equals I of y, 1,500. So here, 11,907. And I'm just going to go ahead and do this with the calculator since we redone it with Excel and the formula on the last one. So I'll just do one with the financial calculator. So here, 3 and enter. In this case, the interest rate is no longer I over y, so I'm going to hit I and y, and then I hit enter. And guess what? Future value, you know what? I already have that entered. 0 is a payment. I can just go ahead and hit compute present value. And there it is, negative 11,907 and 48 cents, rounded down. So at 8%, right, I have to basically have less money or invest less money now to get those 15,000 in 3 years. And in this case, the difference is $686.81. Basically, what I needed before was 12,594, and what I need now is 11,907. Okay. So there are 4 points to the equation: present value, future value, interest rate, and the number of time periods. If we know three, we can get the fourth. For the computer, I'm sorry, for Excel and for the calculator, if the cash inflow is positive, the cash outflow is going to be negative, and vice versa. Uh, the discount rate. Now we can do a simple algebra to solve for R here, right? So basically, the future value is the present value, 1 plus R to the T. So let's do this. So basically, first I have to divide by P over T. So I have the future. Oops. I always do this. I got to do it. Right. Future value over present value equals 1 plus R to the T. And then, right, once I have that formula, I have to basically take the exponent to cancel this T out and bring it to the other side. Cancel this T out and bring it over here. Basically multiply or take the exponent 1 over T on both sides. So and of course over here on the right hand side of the equation, I have 1 plus R. And basically, right, I'll have T multiplied by 1 by T. They cancel out and it's just 1. So it's 1 plus R to the 1. And that's what I have. So I bring the 1 to the other side and I get this equation here. R is equal to future value divided by present value to the 1 over T's power minus 1. Right? Now in the calculator, I can get this formula using the y to the x key, where x is going to be 1 over T. And basically the 1 over T, or the x, right, I can use using the 1 over x key. Let me show you where that's at on the financial calculator, which is right here, right above the y over x. Okay. So I'm looking to invest, right? Looking at investment that'll pay $1,200 in 5 years if I invest $1,000 today. What's the implied interest rate in this case? Well, I know everything else. I know the number of periods, which is 5 years. I know my present value, which is 1,000. I know my future value, which is 1,200. Basically, all I need, right, is to calculate the interest rate, R. So here I have 1,200 over 1,000 to the 1/5 power minus 1. That gives me 0.301. So let's go ahead and do this on the calculator. I'll do the formula on the calculator. So my future value is 1,200 divided by 100. I'm sorry, 1,000. and that equals 1.2, right? I want to elevate that to, so y, uh, let's go ahead and do one, actually, you know what, it's easier to do it this way. I have 12,000 divided by 1,000, which is 1.2, right? So I hit y to the x, then I'm going to hit 1 over x, and I hit 5, and that'll give me, no, it won't. Okay, let's do this again. Over x is 0.2, and that's what I need to elevate it to. So I have 1,200 divided by 100, or 1,000, right? And that gives me 1.2, 0.2. That gives me 1.0371. I I subtract off the 1 in the formula, and I get 0.0371, and of course I rounded it before. Okay, now let's do it with the financial calculator. The number of years is 5, so 5 and enter. The present value is 1,000, but in this case, it's our inflow. We're going to make it negative. So present value negative 1,000, enter. Payment 0, which is default. 1,200 is going to be my future value, enter. And I want to hit compute, I over y, and voila, I get 3.7137, rounding up is 3.34. Now finally, let's do the rate here. So I have rate. I have the rate. The number of periods is 5. Payments is, of course, 0. In this case, my present value will make negative. And my future value is 1,200. And the type is going to be 0. Just, you know, that's a default. And I don't know why it would give me a dollar sign there, but that's a dollar sign anyway. It's 0.03714, which is what we got here. Okay. Alrighty. So here we have another example. Suppose you're offered an investment that will allow you to double your money in 6 years. You have $10,000 to invest. What is the implied interest rate? So we could do this with the calculator, Excel. I'm going to go ahead and do this with the financial calculator. So here we have 6 years is n, so 6 and enter. The present value, we're going to do negative. So negative 10,000. PV, enter. Payments is of course 0. I'm going to leave that alone. And I want $20,000 after these 6 years. So 20,000 future value, enter. That's what I want. I want to double my $10,000 is $20,000. So here what I want to do is, after I hit enter, I want to hit compute, I over y, which will give me the interest rate, which in this case is 12.2462, or rounding up is 12.25. Let me go ahead and do this in Excel. It's probably going to give me, in this case, the number of periods is 6. And payments, of course, 0 because it's a one-time thing. The present value, negative 10,000. The future value, positive 20,000. And of course, it's at the end of the period, it's type 0. And I get 12.24. I have something that Doing the dollars, and let me get rid of that. No, I don't want this in currency. I want this general. There we go. Actually, let me do this in percentage, just so percentage. There it is, 12.2462%. Okay. All right. Uh, Next example, suppose I have a 1-year-old son and I want to provide $75,000 in 17 years towards his college education. I currently have $5,000 to invest. What interest rate do I have to earn to make that $75,000? Uh, these ones I'm going to go ahead and skip and just show you. All right. With the calculator, right, 17 and enter. The present values, which I have, 5,000, negative 5,000, because this is what my inflow. PV enter, 0 PMT enter. Of course, that's the default. I don't have to do that. My future value is 75,000, so 75,000 FB enter. And then I hit compute I over Y, and it should give me 17.27. I can do it in Excel. We just type equals rate. The number of periods are 17 years. That's how long I have till my son becomes college age. The number of payments, because I just put the $5,000 in, I don't put any more in, is 0. My present value is negative 5,000. My future value is 75,000. And that gives me 0.1727, which is 17.27%. Okay. What are some situations you want to compute the implied interest rate? Suppose you're offered the following choices. I can invest $500 today and receive $600 in 5 years, and the investment is considered low risk. Or I can invest $500 in a bank account paying 4% annually. So basically, what I want to do is I want to figure out what the implied interest rate on the first choice is. Is it greater than 4% or less than 4%? Okay. Sorry, I couldn't get rid of the pointer. So here it is, $500 a day, get 600 in 5 years, or just put the $500 in the bank earning 4% annually. Uh, I can do it with the formula 600 over 500, 5 years, 1 over 5 minus 1 gives me 3.74%. I can do it with the financial calculator 5 and enter, negative 500 present value enter, 0 payments, 600 future value gives me 3.74. So in this case, right, uh, the 4% that the bank would pay me would give me more, right, than the $600 I get in this investment. So I'm better off putting my money in the bank in this case. Okay. Now we figured out how to do R. How do you do uh, when you have the future value, the present value, the interest rate, and of course payments are 0? Uh, how do I do this? I want to compute N. Now, first we have the formula, and basically we're solving for T, right? So basically what I have is the following, right? Again, get back to the laser pointer. Oops, not the laser pointer, the pen now. I divide both sides by present value. So my future value divided by present value is equal to 1 plus r to the t power. Now we want to solve for t, but t is is in the exponent up here. So how do we do this? Well, if you remember your algebra, if I take the natural log, so basically x, I always do that. I take the natural log of both sides. So basically I have the natural log of FV divided by PV. Now, one thing that doesn't really matter for us right now, I could also write this as a log of FV minus a log of PV. That doesn't matter. What's important is what's on the left-hand side. What I have now with that exponent, I'm going to have T times the natural log of 1 plus R. So now to get this, I just divide both sides by the, oops, I didn't write the natural log, did I? So ln, hopefully you can see this here in the blue, 1 plus R. So basically I'm going to divide both sides by the natural log of 1 plus R, and this is what I have here. So T is equal to the natural log of FV over PV divided by the natural log of 1 plus R. And of course, if I plug both these in, if I plug future value, present value, and the interest rate, I just have to compute in with the calculator. Or in Excel, right? I basically type the formula for the number of periods, and put the rate, the payments, which is 0, present value, and future value. And payments in this case, in our case now, is 0. Next chapter, we'll change that assumption. So here we go. I want to purchase a new car, and I'm willing to pay $20,000. If I can invest at $10,000 per year and currently have $15,000, how long will it be before I have enough to pay cash for the car? So basically, I have $15,000. I'll earn 10% per year. How long before I have that $20,000 to buy the new car? Let's go ahead and do it with the calculator. So basically, what I'm going to have is 10 is the number, is the I over Y, the percentage. So 10 I over Y, enter. The present value is 15,000. That's what I'm putting in, so I'm going to make that negative. So I have 15,000 negative present value, enter. The future value is 20,000, FV, enter. And of course, the number of payments is 0, so I'm going to ignore that because that's the default. And I just want to hit compute N. And voila, I get 3.0184 rounded up to 3.02 years. Now with Excel, I want to do the number of periods. So the first one is a rate, and in this case is 10%. Again, it's decimal, so it's 0.1. The number of payments is 0. The present value, I want to make negative. But you know what? I'm going to do something just to show you. I'm going to make it positive. I'm going to make the future value negative 20,000. By the way, I use the commas here, so don't use the commas when you're doing the thing. And I'm just going to close that. The default is 0, and boom, it gives me an error. Why? Because I didn't make either the payment, the present value, or the future value negative. I'm going to go ahead and make the present value negative, and oops, let's see. Okay, I did this in percentage. I just want to make it general. Uh, and there it is. 3.01837718. Rounding up is to 3.02. I had in percentage, and of course it screwed up because I had the percentage from the rate that I was doing before. Okay. Okay. We can also do this with the formula, right? 20,000 over 15,000 is 1.333. The natural log of 1.333 is 2.877. Uh, Here, basically, when you take the natural log, you're going to have to do this with, oh no, we don't. Okay. So doing it with our calculator, right? I'm going to hit 20,000 divided by 1.5 by 15,000 gives me 1.333. That's 4. And now what I want to do is I want to take the natural log, and the natural log you see right here, and that gives me 0.2877. Now, 1 plus the interest rate is 1 plus 1, 0. Uh, I can save it or I can just write it down. So 1.1 natural log gives me 0.0953. So to get t in this formula, I'll have 0.2877 divided by 0.0953, and that gives me 3.189, or basically 3.02 years before I have enough money at 10% to spend $20,000 on that new car. Okay. When might you want to compute the number of periods? For instance, here's an example. Suppose I want to buy new furniture for my family room. I currently have $500. I want furniture that costs $600. Right? I can earn 6%. How long do I have to wait if I don't add any additional money? Well, in this case, right, let's go ahead and do this with the calculator. Uh, so that's 6. I over y is the interest rate. Enter. In present value, it's 500. I'm going to go ahead and make that negative, so it's my inflow. PV, enter. PMT is 0, we know that. And my future value, I need $600 to buy that. 600 future value, enter. And now I want to compute N. That gives me 3.13. Voila. Okay, I can do it with the formula. I have 600. Well, actually, let's do, yeah, I have 600 divided by 500, and that equals 1.2. I take the natural log, it gives me 1.823. I want to divide that by 1.06, right? The natural log is 0.0583, and that gives me, again, 3.1290. Ooh, I didn't show you that. Let me go ahead and show you that. I thought I was doing it. Okay, 600 divided by 500 gives me 1.2. I take the natural log, which is 1.823. I divide that. Here I hit the divide, the dividend, by 1.06. That's 1 plus the interest rate, 6% in this case. The natural log, which is 0.0583, and I hit equal. That gives me 3.129 or 3.3 years. Okay. And finally, we'll do it in Excel. Okay. The number of periods. First thing is the rate, which is 6%, which is 0.06. Again, we got to do this in decimals. The number of payments is 0 because it's just a one-time thing. The present value is 500, and of course that has to be negative. The future value is 600, which will be positive. I just hit it. 0. The type is default is 0, and I hit enter, and I get 3.1289, or rounding up to 3.3. Okay, return to the quiz. Okay. Many financial calculators are available. Click on this link to go to the present value of money chunk. Right? I need $40,000 in 15 years. I can earn a 9.8 interest. How much do you need to invest? Now you can do this in money chunk, but we can do it with the calculator. Basically, what money chunk does is it gives you the formulas, and here we have the present value, right? Right, the interest rate is future value, the present value 1 over y minus 1, which we figured out that's how much 1 plus the interest, oh, I'm sorry, what the interest rate would be, and of course the present value. Okay. Now we can do this. I need 40,000 in 15 years. I can earn 9.8% interest. How much do I need to invest today? Well, in this case, let's go ahead and do this with the financial calculator to figure out how much I need in present value terms. Oops, sorry. What I need in present value terms. So let's go ahead, and 15 is the number of years, n, so 15 and enter. The interest rate is 9.8, so 9.8 I over y, enter. The future value is 40,000, FV, enter. Number of payments is 0, so now what I want to do is compute present value. Negative 9,840 and 68 cents. They didn't do the thing, but I could have done this with the website. But I figured we'd do it with the financial calculator instead. I can also do this, of course, with Excel. So here I want present value. The first thing I want to do is the rate. In this case, right, 0.098. Again, it's in decimals for the rate. The number of periods in this case is 15 years. Payments is, of course, 0. Future value is 40,000. And type 0. So there it is, $9,840.68. That's how much I need now to get 40,000 in 15 years at 9.8% interest. Okay. So basically here is a summary. The present value is what future cash flows are worth today. The future value is what cash flows are worth in the future. The interest rate or the rate of return, the discount rate. Basically, we use these interchangeably depending on what we're doing or what the application is. T is the number of periods, usually in years, but it can be in months. And C is the cash amount. The future value is C, where C is basically the present value, 1 plus R to the T. When 1 plus R to the T is called the future value factor. The present value is PV over C, where C is future value, 1 plus R to the T, where 1 over 1 plus R to the T is called the present value factor. I multiply whatever future value I have times that number, and it gives me the present value. And the basic present value formula is PV is equal to FV. Now this T denotes how long in the future that's going to be, 1 plus R to the T. Uh, all right, we've already done all these examples. So that's basically it for this lecture. Like I said, now I probably don't have access to email, but if you email me when I get back in less than a week or so, I should be able to answer you. Okay, that's it. Take care. I hope you understood what was being taught. Bye bye.